Myth number 2, titanium's perceived durability. It is not uncommon for those who own a titanium chair to make the following statement. I bought my titanium chair because it's the most durable chair made. Is this really true? Intuitively, we all understand the importance of design. We watch the shapes of bridges and buildings change throughout history as engineers learn more about the nature of force. And like architectural engineers, wheelchair engineers similarly develop better ways to absorb, deflect, or redirect force. Because force is what causes things to break. To understand how force affects a chair, let's first look at what happens when a wheelchair hits a curb. In this type of impact, the frame's role in absorbing force may be far less important than what most people think. The caster wheel is the first to absorb the impact, followed by the fork, and then the stem. The frame is only a part of the overall equation. But let's assume that frame is what we are concerned with. Let's take a minute to look at what scientific research has to say about the role of aluminum and titanium in frame design. Consider the recent 2010 published study, Evaluation of Aluminum Ultralight Rigid Wheelchairs versus Other Ultralight Wheelchairs Using ANSI-RESNA Standards, by Lewin Cooper et al. From the University of Pittsburgh. Here is what this study found. We hypothesized that the AURWs, aluminum ultralight rigid chairs, would be more durable than the TURWs, titanium ultralight rigid chairs. Across wheelchair models, no significant differences were found in the test results between the AURWs and TURWs, except in their overall length. The study's detailed analysis of what caused each chair to experience a catastrophic or type 3 failure points to an overall conclusion. Nowhere in the analysis did the research group blame the failure on the overall strength of titanium as a metal. In each instance, the cause was attributed to the design or the manufacturing process. The group summed up its findings as follows. The frame material does not directly affect the performance and durability of aluminum versus titanium ultralight rigid wheelchairs, but proper wheelchair manufacturing and design based on the material properties are important. It is the principles of design and engineering that really count. To better understand this emphasis on design, consider this stress analysis. The scale to the right of the tube indicates stress level. Red is the highest and blue is the lowest. A common design technique is to change the shape, in this case, to an oval. Both tubes in this example use the same alloy, yet the oval tube is 11% stronger. This clearly illustrates that design, by itself, can affect durability. To further support the findings of the previously mentioned 2008 study, a comparison of actual field failures was conducted. Two chairs with similar frame designs, the aluminum Quickie GT and the titanium Quickie GTI, were used. The percentage of frame failures was substantially less for the aluminum Quickie GT. Additionally, of all the failures that would render this chair unusable, frame failures had the lowest occurrence. So what does all this data point to? Overall durability is primarily a function of design and manufacturing quality, not the choice of materials by itself. To look at it any other way is simply a myth.